welcome to Martin Maths. Today we're going to be doing bearings.
Okay, my guest presenters are going to help me with a maths problem. We're going to use some trigonometry, some Pythagoras, some angles to help solve a bearings question. What is the question?
A search and rescue team travels 73 kilometers on a bearing of 243 degrees. They then need to go a further 2 kilometers in the direction 153 degrees to reach the missing vessel. How far away was the vessel, and what initial direction would have led the team straight to the vessel?
Okay, was that 153 after they've made their change?
Yeah.
So 153 there and 2 kilometers in that direction. Okay, what do we do?
Before you start, make sure you read from 0 north and then go clockwise.
Okay, so always remember that. When you're measuring bearings, if you're drawing a picture to give yourself an idea, use a protractor, 0 is at north, and read clockwise. Okay, what can I do with some of the angles we've got?
So, to find point P, like the interior of point P.
This one here? Yeah.
To find that angle, we do 360 minus 243.
So 360 minus 243 gives us?
117.
So that gives us that angle there. Why does that help us?
Because that will help us find the, later on,
The angle over here, the angles between parallel lines, because both these lines here are both going north, so they're parallel, so we can use co-interior angles to find that angle there. Let's call that T for turning and V for the final vessel, right? So how do I find out what that angle, the dot angle there is?
so we do 180 minus 117, which gives us 63.
So that angle there is 63. So we've used angles around a point and we've used parallel lines. Okay. How does that help us?
Well, it helps us because when you say like 153 minus 63, it will give you 90. That way you can know if your triangle that you can connect, if it's a right angle, so you can use Pythagoras.
So we've got a right angle triangle here now. So now we can use Pythagoras to find its hypotenuse, to find the distance P to V. So what is P to V? How do we work that out?
So you're gonna say 73 square plus 2 square is going to give us V to P square, which is going to be...
We can use our calculator to work that out.
Okay, so 73 square plus 2 square is 5,733. When you square root that, your answer is going to be 73.02.
Okay, and watch some other videos on Pythagoras to see how we can work that out. So 73.027, but to 3 significant figures, it's also 73, which is the same as that one because at that length of distance, that we're not too far out. Okay, but obviously the vessel should have gone out on the correct bearing. So how do we work out what the correct bearing was that they should have set out to get there straight away?
We do 10.
So if we look at this triangle, that's the opposite, that's the adjacent. So we've got to use some trigonometry. And we do tan of that angle. We call it Z. Yeah, and tan of that Z is?
2 divided by 73.
2 divided by 73. So how do we find out using our calculator?
Shift 10.
Shift tan.
Bracket.
Yeah.
2 divided by 73. Bracket.
Yeah, and we get an answer of?
1.57.
So as you can see, that angle correction is very slight, only 1.56. So the correct bearing should have been?
241.
So 243 minus that answer, 241. So they should have set out at a bearing of 241. There we go. We've solved that problem using angles around a point, using parallel lines, using Pythagoras, using trigonometry.
Thanks for watching. Like, share, and subscribe.
And goodbye from all.
Bye.